let's look at the properties of logarithms. These are very similar to the properties of exponents, but they're in log form now instead of exponent form. So let me give you our first example. This one, I have log base b of 1 will equal 0. This is basically the same thing as anything to the 0 power will equal 1. It's that rule, that a property of exponents, but in log form. So basically for logarithms, no matter what the base is, if you're putting a 1 in, the answer is always going to be 0. And then we have log of the same base rule, which says if the base and the input are the same, the answer will always be 1. And you'll probably notice that this is the same thing as anything to the first power is itself. So it's that rule, it's that property of exponents, but turned into logarithmic form. The next three rules we'll be using a lot today, so pay attention to these ones. We have the product rule, which says if I have a logarithm of any base of x times y, that's going to turn into the logarithm of x plus the log of y. So basically this kind of looks at like our exponent rules, that when we multiply we add the exponents. That's a similar thing here. When we're multiplying here, we're going to end up adding. Except notice that I start with one logarithm multiplying and I go to multiple logarithms adding. So I'm expanding the logarithm to have more logarithms. Quotient rule is similar. If multiplying turns into adding, then it would make sense that dividing turns into subtracting. And our last rule is the power rule. The power rule is probably the weirdest one. It only works for logarithms. But it says if I have x to the n in my logarithm, I can actually take this exponent right here on this x, and I can move that exponent out in front, which is kind of a weird thing. We don't usually move exponents out of the exponent place. Logarithms is the only place where that works, where we can take this exponent and just decide to plop it out in front instead. Now, before I move on with the rest of the properties of logarithms, I actually want to skip ahead to examples 6 and 7, where we're just going to take a moment and prove that these two properties do work. Why does the division turn into subtraction, and why can we put the exponent out in front? Why does that work? So we're going to come right here and start with the division one. Now, for this division one, I know that this v has a little secret 1. So I can use my properties of exponents that we talked about last class, and I can bring this v up into the numerator, and all that's going to change is the exponent's going to change signs. That was one of those properties of exponents we did last time. So bring this v up, and the little secret 1 turns into a negative 1. And now, look at this, I have multiplying here. Well, we just talked about our properties of logarithms, where multiplying is going to turn into addition. We also just talked about a property that said I can take this negative 1 here and I can move it out in front. So let's do that. So if I move a negative out in front, that's going to turn that plus into a minus. And ta-da! Our division turned into subtraction. So that is why that rule works. Now let's talk about this one. This one's my favorite because it's such a weird rule that you can just move the exponent in front and that works. So let's talk about really quickly why that works. Now, for this case, this problem, I'm going to have you make v a 4. But you can make v any number and follow this same pattern, and it will still always work. But we're just going to use 4 for today's example to kind of simplify the problem down. So we're going to start right here with this one. Now, I know that u to the fourth is the same thing as u times u times u times u. That's u to the fourth. And I also know that all of these multiplications can turn into additions using our log property. So I'm going to change the multiplication into addition, and then change the multiplication into addition, change the next and final multiplication into addition, and I have this. Now this we can simplify. Think of it like this. What if instead of logs they were just x's and I had x plus x plus x plus x? You would tell me that would simplify to 4x. Well, same thing here. If I have log plus log plus log plus log, that's going to simplify to 4 logs that I am adding together. And hey, look at that. The exponent moved out in front. So that is why we're allowed to move that exponent out in front, is because the exponent turns into multiplication, turn that into addition, and then we combine them together, and the exponent kind of just moves in front. It's kind of a cool rule. Okay, so that's all we're going to do in this video. In the next video, we'll talk about our last 3 log properties.